Welcome to Study Loop.
This problem says a particular variable measured on the U.S. population is approximately normally distributed with a mean of 118 and a standard deviation of 24. Consider the sampling distribution of the sample mean for samples of size 9, and we are asked, according to the empirical rule, in approximately 99.7% of samples, the sample mean will be between what two values for the lower bound and upper bound? And since we are looking at a normal population, that means we can treat our sampling distribution as approximately normal as well. And with normal distributions, the empirical rule tells us that within 3 standard deviations less and 3 standard deviations more than our mean, we have 99.7% of our values. And that will hold true for our sampling distribution as well, again, since our population is normal. So within 3 standard deviations less and more with our standard deviation of our sample mean from the mean of the sampling distribution will also hold that 99.7%. And when we're dealing with a sampling distribution, when our distribution is normal for the population, the mean of our sampling distribution is equivalent to the mean of the population, so that will stay 118. But the standard deviation of the sample mean will be equal to the standard deviation of the population divided by the square root of the sample size n. So in our case, that's 24 divided by the square root of 9. That gives us 24 divided by 3, which means the standard deviation of the sample mean would be 8. So for our 99.7%, that will be our mean of our sampling distribution, 118, plus and minus 3, times the standard deviation of our sample mean, which we found to be 8. So that would give us 118 plus or minus 24. And when we subtract, we get our lower bound, and 118 minus 24 gives us 94. And when we add, we'll get our upper bound for the 99.7%, and 118 plus 24 gives us 142. So that's our two values for the lower bound and upper bound.